student, today I will discuss about the Schrodinger wave equation in one-dimensional particle in a box. It is a very important topic. Suppose according in the Schrodinger wave equation application, the particle in a box in infinite square well potentials, particle in one-dimensional and back and forth motion, that is in this direction the potential infinite and wave function psi in this area psi it is equal to 0, and in the infinite square well potential psi is not equal to 0, and in this place psi it is equal to 0. Given the conditions x it is equal to 0, 0 is less than x is less than L, x it is equal to infinite, x is greater than 0, x is greater than equal to capital L, and according to the Schrodinger wave equation in one dimension for the free particle, they were square psi, they were x square plus 2m h bar square e psi it is equal to 0. For free particle v it is equal to 0. For this equation, the solution such type of these equations, solution of this equation psi k it is equal to 2m e upon h bar square, or k it is equal to under root 2m e upon h bar square. The equations they were square psi, they were x square plus 2m k square psi it is equal to 0. Equation number 2. Such type of the equation, the solution of these equations, the psi it is equal to a sin kx plus b cos kx. Equation number 3. Equation number 2, the solution of equation number 3 is the solution of second equation. For this equation, the boundary condition which will be used, first condition psi it is equal to 0. Psi it is equal to 0 at x it is equal to 0. Psi it is equal to 0 at x it is equal to 0 in this box. Then 0 it is equal to a sin 0 plus b cos 0. The value of sin 0 which is equal to 0. So 0 it is equal to 0 plus b, then value of the b is comes 0. And second boundary condition is used, psi it is equal to 0 at x it is equal to L. Psi it is equal to 0 at x it is equal to L. Then from this equation, third, 0 it is equal to a sin kl plus 0, because of that value of the v which is equal to 0, then 0. It means a sin kl it is equal to 0. It means a and sin kl which is equal to 0. it means A does not equal to 0. Then sin KL, it is equal to 0. It means the value of the sin n pi which is equal to 0. Then we write it sin KL, it is equal to sin n pi. Because of that, the value of sin n pi which is equal to 0. Then k it is equal to n pi upon L. K it is equal to n pi upon L. This is the value. Then value of the energy eigenvalue in the different energy levels from this equations. K square it is equal to 2m E upon h bar square. Then E it is equal to k square h bar square upon 2m. The value of the k put and h bar it is equal to h upon 2 pi. H upon 2 pi. Then energy eigenvalue E n it is equal to n pi upon L whole square and h upon 2 pi whole square upon 2m. Then energy eigenvalue in the different energy level n square and pi square is also cancelled, n square h square upon 8 ml square. These are the energy eigenvalue in the different energy level, and it is equal to 1, 2, 3 dot dot in the levels, which is the energy eigenvalue in the different energy level. Then after that we find the normalization form of these equations. Then which is comes the wave function from equation number 3. Psi it is equal to A sin 2 pi x upon L. Equation number 4. Then apply the normalization conditions. Minus infinite to plus infinite mod psi square into dx which is equal to 1. What in this given the in this question the limit x it is equal to 0 to x it is equal to L. Then 0 to L and a square sin square 2 pi x upon L into dx it is equal to 1. Then we know that the sin square theta it is equal to 1 upon 2 1 minus cos 2 theta. This is the formula. Then a square 0 to L 1 upon 2 outside, then 1 minus cos 2 pi x upon L into dx it is equal to 1. A square upon 2 0 to L 1 into dx plus minus 0 to L cos 2 pi x upon L into dx, it is equal to 1. Then the integration which comes a square upon 2 x limit 0 to L and minus sine 2 pi x upon L or upon 2, the limit 0 to L which is equal to 1. Then we apply the limits a square upon 2 and L minus, which is the apply the upper condition and lower condition. Upper condition sine 2 pi x and value of the sine n phi x which is equal to 0 and sine 0 value which is also 0, but then the both limit which is equal to 0 and it is equal to 1. Then a square upon 2 into L, it is equal to 1. It is equal to 2 upon L, a square, then it is equal to under root 2 upon L. The value of a, it is also put in the equation number 4. Psi, it is equal to under root 2 upon L into sine 2 pi x upon L, this is the normalization form of the wave function.